Today, I will introduce about choosing the right resistor for your application. The most important thing in choosing a resistor is, of course, the value of the resistor. As you may well know, resistors serve to limit the current. Let's look at this simple circuit below. This circuit consists only of a voltage source. In this case, infinite current flows. Of course, under the assumption that the current capacity of the voltage source is infinite. If you add a resistor in this circuit, the amount of current flow is limited to a value of V divided by R. The famous Ohm's law. Let's check the IV curve of the resistor to see the relationship between the voltage and the current according to the resistance value. As the voltage increases, the amount of current increases linearly. The slope of this line is 1 over R. In other words, as the resistance value decreases, the slope increases and more current flows. The resistance value of a commonly used resistor ranges from 0 ohms and up to tens of megaohms. After choosing the resistance value, you need to check the tolerance of the resistor. Resistors can have a tolerance range of 0.05% up to 20%. 1% or 5% tolerance resistors are mostly used. For example, a 10 kilo-ohm resistor with a tolerance of 5% can have a resistance value between 9.5 kilo-ohm and 10.5 kilo-ohm. So you need to check whether this range is tolerable in your circuit. The next thing to consider is the temperature coefficient of a resistance, or TCR. This indicates how much the resistance value changes according to the temperature change. It is defined as the resistance value in ppm per degree, referenced at 25 degrees. For example, the resistance change of a 50 ohm resistor which has a TCR of 20 ppm per degree is 0.001 ohm per degree. This is the result of multiplying the resistance of 50 ohms by TCR of 20 times 10 to the -6. The next specification to consider is power rating. If you refer to the IV curve of the resistance you saw before and draw the change of power according to the voltage, you can obtain a curve that increases as a quadratic function. This is P equals V squared divided by R. When the power consumed by the resistor increases, heat is generated accordingly. Excessive heat may cause the resistor to break or burn. Therefore, check what the power rating value is, and use it within a safe range. In other words, power rating refers to the maximum power value that a particular resistor can withstand. The power rating of the resistor typically increases with the size. Following table is the relation between the power rating and the size of a chip resistor. You also need to check the ambient temperature for which the power rating is defined, which is usually specified based on 70 degrees. Next is the maximum operating temperature. Maximum operating temperature is the maximum temperature at which the resistor can be used normally. When current flows through the resistor, heat is generated depending on the amount of power consumed. Therefore, the combined temperature of the ambient temperature, and the heat generated by the power must not exceed the maximum operating temperature. Then, how can you find the heat generated by power consumption? If you look at the resistance datasheet example, there is an item called thermal resistance. It is defined as Kelvin per watt, and it is the measure of temperature rise per 1 watt of dissipated power. Therefore, the heat generated by the power consumption of the resistor is the product of the power consumption and thermal resistance. Let's take an example of a resistor called SFR16S from the previous table. The maximum operating temperature of this resistor is 155 degrees, the power rating is 0.5 watt, and the thermal resistance is 170 Kelvin per watt. Assuming that this resistor is used to consume 0.5 watt, the heat generated from the power is 85 Kelvin. Since the ambient temperature is 70 degrees, the temperature of the resistor equals 155 degrees by adding these two values. This is the same value as the maximum operating temperature, so it can be used under this condition. If the ambient temperature rises above 70 degrees under this condition, the temperature will be higher than the maximum operating temperature and damage the resistor. In this case, you should consider using a resistor with a larger power rating or reducing the power consumption. When the ambient temperature of a resistor can exceed 70 degrees, the power should be limited in order not to exceed the maximum operating temperature. This is the power derating curve you might see in the resistor datasheet. When the power rating is defined at 70 degrees, it tells us that a resistor can be operated at a power equal to the power rating when the ambient temperature is below 70 degrees, but should be reduced when operated at a temperature above 70 degrees. The last specification to look at is voltage rating. This is the maximum voltage that can be applied to the resistor. Beyond this, the resistance may be damaged. Let's summarize what we learned today. The main specifications for selecting a resistor are: first, the resistance value. And you should take into account the tolerance of the resistance value whether it is suitable for your application. The second is the power rating. Make sure that the power consumption of the resistor does not exceed the power rating. Next is the operating temperature. The temperature rise due to the ambient temperature and power consumption must not exceed the maximum operating temperature. Since the resistance value changes according to the temperature change, it is necessary to take this into account. Power derating should be considered when a resistor is operated above the temperature where the power rating is defined. Voltage rating should be considered for high voltage applications, especially for AC applications. There is a link for a spreadsheet for checking whether a resistor is suitable for your applications. Notes are included in the spreadsheet for better understanding. Please leave a comment if you have any questions or comments. This is it for the video on how to select a resistor. Thank you for watching. Have a good day.